So today it is my great pleasure to welcome Mohamed Adel- Abdelkader. I'm so sorry if I said that wrong. I should have asked you much sooner and had some practice time. Um, but I'm so thrilled to have you here today. He's studying civil engineering and just defended his PhD last week, and so soon to be minted PhD at let's see, Stevens Institute of Technology, and he recently published a paper that integrated some of the Globe Observer observations of river ice with satellite data, and we thought it was really interesting work, getting into some things that we had long looked at doing, and so we wanted to hear a little bit more about that work and give our community opportunities to ask questions about his approach and maybe how ideas about using data. So welcome, and I'm going to give you the floor to give a short introduction to your work, and then we can open up for questions.
Sure. Thank you so much, Bari, for the introduction. First, I want to thank Amy. She put something in the chat. Thank you. I'll go ahead and share my screen. Yeah. So those efforts, it was a joint project with Stevens Institution of Technology, Fresh Eyes on Ice community in Alaska, and Globe Observer. But most of the credits definitely goes to the observers and citizen science that contributed with their images. So this work came to publication, and it's supporting research and, most importantly, operation. And I think that's the added value of the research or the work that we did here, that it's supporting operations, and mainly we are supporting NOAA and local governments with this integration of remote sensing observations with citizen science contribution. So a little bit of background. The case study that we conducted was in Alaska. So we all know that warming climate is affecting river ice dynamics. So by that we mean that it's impacting the timing where rivers is starting to freeze, the timing where rivers start to break and we start to have open water and fresh water running again. And recently we noticed that there are some changes in midwinter breakups. So we start to observe more and more ice breaking up during winter, and that disturbs the transportation and the local safety of communities, especially in Alaska. So as I mentioned, we did the case study in Alaska, leveraging both Fresh Eyes on Ice observations and Globe Observer observations together. We brought everything to an online web-based platform supported by Google Earth Engine, and mainly what we are putting in this platform, some remote sensing products that we are producing. So the information of river ice, we are basically retrieving this information. We get images from satellites and we detect where there is ice and where there is open water. I will show one slide detailing how we are doing that. In addition to that, we are directly displaying satellite images that already exist in the cloud. We can classify them to optical images similar to what we have in our phones, just cameras that are taking pictures from the sky or from the space. And the added value here is to implement ground-based observations. Part of it is coming from community observations from Fresh Eyes on Ice and Globe Observer, and the other part is coming from webcams, either deployed by Fresh Eyes on Ice team or USGS high-vis cameras. So just in a nutshell, to summarize what we are doing here, is we are trying to create a unified system to monitor river ice by combining multi-source data sets. So this is how the interface look like. The product that you are seeing here is showing where we have frozen river, where we have open river. I would say, for instance, here there are some open rivers since they are connected to the ocean. So users, either community from Alaska, either operational agencies like NOAA, they can directly get to this website, see where they have frozen rivers, where they have open water. They can detect when the ice or rivers start to freeze, when rivers start to break. And to validate this product and to give more confidence, The product is supported by the citizen science observations. We are merging both data sets together from Fresh Eyes and Eyes and Globe Observer. So simply the user what can do, just zoom in on the region of interest, click on those dots if he's interested in historical data or more recent data, and then a link will be provided to those observations. Regarding the remote sensing product, so the cornerstone stone of the system is VIRS-based product. So there is one sensor called VIRS. It's a visible infrared radiometer suit supported by NOAA. This sensor is on top of 3 different satellites. One was launched in 2012. There is a second satellite launched in 2019, and recently the last satellite was launched in 2021. So those satellites that are continuing the legacy of MODIS that probably most of you are familiar with the MODIS to support daily observation of land surface. So basically what we do, we take those observations and we classify those images to different classes, land cover classes, water, land, vegetation, snow, river ice, cloud, and cloud shadow. And this retrieval of the information, how we classify the land cover, is based on machine learning algorithm. So we just feed those images to a trained model, and the model will take care of classifying those images. The process itself is quite straightforward. We take data from NOAA, we process it, we generate those images, and then we upload it to the cloud, specifically to Google storage buckets. So Google, they provide this service where you can store any kind of images or data in their cloud services. And then from Google Earth Engine platform, we just take those images and we display in this web-based application. In addition to that, we get the citizen science data. Also, we upload those citizen science data to the cloud. The process is done automatically. So Fresh Eyes on Eyes, they made this task easy. They have a direct API for those observations merged from their observation and from Globe Observer. We just take that data and we display it in real-time mode, or when those observations are available. Here, just wanted to show a couple of cases where really the citizen science contribution was amazing. It was really helpful to analyze and understand some ice-induced hazards and how we can better monitor them. So here, for instance, this is the VIRS product that we display from Stevens. We can clearly see where we have ice, when we start to have open water. This water here is representing the extent of the flooding. This is another image from Sentinel-2. It's showing higher resolution. It's showing exactly the extent of ice, the extent of open water. But again, we don't have an idea about the depth of the flooding or the damage associated with this ice-induced hazard. So here, the citizen science contribution came very handy. So based on that, we can assess this hazard, and this is really important for building predictive models later on. We can leverage the remote sensing products and those images to train models, either normal hydrology models or machine learning models to detect, for instance, ice jams. But there is a missing information, which is the damage and flood depth. And here from remote sensing, we are not able to retrieve this information, but with the contribution of citizen science, we can have better understanding what happened during specific events. This is another case in 2023. So here we have an ice jam took place in Alaska near Mosquito Fork Bridge. So the satellite observation showed us exactly the extent of the ice jam. We know where is the ice jam, but we have no idea what type of ice is there, how we can control it. And like the contribution of citizen science came very handy to help us to understand what's exactly happening in this reach or in this channel. Now, as I mentioned, that we start focusing on Alaska, especially that there is rich database from both the Globe Observer and from Fresh Eyes on Ice. In Alaska, the community there, they are quite active. They are very supportive for research operations. But on continental scale, now we are starting to leverage Globe Observer land cover observations. We start to integrate that in our platform. And starting from this season, I guess, like in a couple of months in Northeast and maybe in a couple of weeks in some other regions in northern watersheds in the US, we start seeing ice starting to form. So what we started doing is we are getting Globe Observer data through the API. By the way, any user who is interested in Globe Observer API, it's well documented, it's quite comprehensive, it's easy to use. So our target that we leverage those observations to support the operation on continental scale, covering, I would say, at least most of the 5 or 6 large watersheds in northern US, starting from northeast up to Missouri Basin and so on. So we started already the retrospective analysis and seeing how our product is compared to citizen science contributions. In the Northeast, this is from Northeast Lake. The product, you can see it's, for instance, it's limited when it comes to resolution. We can capture a large lake, but we have difficulties in capturing small lakes. And we hope that citizen science continue to support those efforts and we see more land cover observations during next winter season. But as I mentioned, starting from September, October, when we start to generate those ice maps again, we'll have both data from Global Observer and the remote sensing together, covering continental scale monitoring of river ice. This is kind of the references that used for those slides. The work is supported, part of it is supported by NOAA, another part is supported by NASA, and I think those are the slides that I have, and I'll be happy to take any questions.
Great. Thank you so much. That was a great overview. All right, I'll open the floor to questions. I have several, but I'll wait for others. Go ahead, Becky.
Hi. First of all, congratulations for your successful defense and the research that you've done. And it's awesome to see what you have done. Okay, you're using citizen science. How do you address skeptics of citizen science and the use of the Globe Observer data and the observations that are being made? How do you ensure the other scientists that that the data that the citizen sciences are created are good? How can you convince me? I'm a skeptic. Nothing that's not done by citizen science is good. How do you address that? Just yes. How do you support citizen science data in what you're saying that you can use that for validating satellites and all of that? Because you probably are going to encounter that at some point. So
yeah,
I
did encounter that during my dissertation defense.
Okay.
Yeah, one member of the committee, he emphasized like, why using citizen science? Why not relying on models and the data that we get from our stations to monitor ice, for instance? And I have another component of water temperature. So for a start, I would say, at least this is my belief, I would say that citizen science is the foundation of observing land surface and Earth. Since the 18th century, 19th century, the first observation in the US was based on citizen science. If we take the 1849 movement, there was almost 150 volunteers across the nation supporting the weather monitoring through their observations. They just see and then they send it. And the nation was relying on those observations to monitor weather across large scale. That's one way how I look at it. And then I see great citizen science. I would mention Benjamin Franklin, Thomas and Jefferson. Both they were citizen scientists and both they were presidents of the United States. Benjamin Franklin, he was the one to understand the northeastern storms through his observation of the wind. Jefferson, if I'm not mistaken, he was the kind of the founder of NOAA through the US Coast Survey, but also he contributed largely to the advancement in hydrology while he was taking notes of humidity, wind, rainfall. So I think that's the base. The start was citizen science, and then we propagated to monitoring weather and advancing weather monitoring with other tools.
Thank you so much. What do you think, Professor Spellman?
Becky, yeah, I was like, the beauty of the land cover app is that there's no wishy-washiness in the way because it's not quantified data, right? And the way that Mohamed is using it, there's no wishy-washiness. You know what I mean? Like, it's a photo. Like, you can't. Well, I guess now you can fake a photo, but nobody's doing that on the Globe Land cover. And most of those critiques, Becky, I think are of complicated protocols, and like anybody that's designing citizen science projects today knows that the more simple your protocol is, the higher quality your data is, and the more it will match, right? But one thing we love about Mohamed, though, is that like a lot of people that are excited about citizen science are a really good person, and maybe like Mohamed is a unicorn because he's got these high-level technical skills. But when he came to Alaska and was interacting with the Globe kids at our symposium, it was like, oh, Mohamed, technical skills and good with people.
Thanks so much. You're a great ambassador.
Yeah.
And Kristen, I see you have a question.
Yeah, it's sort of a follow-up to that because I think our users, our participants love to know how their data is being used. But so what's the message you would want to convey to observers with the app in terms of taking photos, collecting observations that are going to be most helpful to you? And that can be both, places and times, but also are there things when you're looking at the photos, you just say, oh, I wish the observer had done that instead? What advice can we pass along to our observers to make the data more useful to you?
Yeah, I think that's a great question. So for start, I would say the advantage of the images that we are getting from Globe Observer, that it's covering more than one angle. So we have the north, south, and more. That's really helpful to capture the entire landscape, at least in the context of river eyes. We want to see the river and we want to see what's behind the river, if there is snow or it's bare land. So that part, I think that's one need, that the way Globe Observer is getting the data is well covered. But our wish is always more pictures. So that's definitely depends on the will of observers, how much they want to contribute. But to be honest, I'm more closer to Fresh Eyes on Ice. I'm more familiar with the way that they are collecting the data and how much people they are passionate and how much they contribute to collecting data in Alaska. My wish that in other RFCs other watersheds across the US, people, they will be more engaged and they collect more land cover data. It does not really matter if it is during winter time or during summertime. All of those observations, even they don't serve my purpose directly, they will serve other researchers to downscale their product, to enhance their remote sensing products for multi-purpose. But just to sum up, I think more observation will be great.
Well, I don't see any other hands, so I'll ask a follow-on to that. On the flip side, are there any tips you would give to data users who might be looking at integrating Globe Observer photos or other forms of observer data into their research?
Thank you for the question. So I would say I would divide the purpose to two angles. The first one is using the data itself, and then data dissemination. When it comes to using the data, I strongly believe that the way that the data is downloaded, the way to process it is well documented, especially if someone have some familiarity with coding. Even if there is no big expertise to handle large data sets, there is more than one way to deal with the Globe Observer data set. So you have the API, you have the interface. So it's accommodating all the needs, I would say, for research purposes. But when it comes to data dissemination, that's a little bit different. So if someone wants to have his own product and wants to support his product with citizen science observations, then there are a couple of ways to do it. And again, I would say the API and having everything stored in the cloud, or at least there is a way to communicate between the servers where the data is stored and where you want to disseminate it later on. it could be a little bit challenging at the start, but once there is a well-established process, things are straightforward, I would say.
Thank you.
One thing, Holly, and this kind of gets back to what Becky was asking too. One piece of feedback that we've heard for people who are using the fresh eyes on ice photos for like a model validation data set. Like Mohammed's doing visual comparison, and so far all of our papers that have come out using the Globe Observer data are more like visual comparison and rather than a mathematical validation. And the researchers who are trying to use it for mathematical validation, they want it quantified in some way. And so like that's the thrust of our next proposal. The one that we submitted to the NASA Citizen Science Call is like quantifying, using Zoo Universe for people to classify the imagery so that it will be so much easier to use if there's like ones and zeros or percent cover of ice as
right.
a quantified data set rather than just a visual.
Right.
So that's the future, Holly, we hope.
Yay. Well, that's great. And I think I also heard, oh, please go ahead.
No, I said that's amazing. So that's, I think, one of the things that our lab is addressing, but in a different way, addressing images coming from USGS. So it's the same concept. We get images from USGS. So the target is to classify again, but instead of classifying the remote sensing observation, is to classify those images coming from cameras, if you have open water or if you have ice conditions. And that's a way, as Katie mentioned, is to get numbers, and then researchers can leverage those numbers to validate other products. But I just wanted to mention this to Katie, and I have one question. I guess I always want to ask this question. I had this question in mind when I visited Alaska to ask it to Katie, but I forgot to do it. I think now I have more than more than one person to address this question for. So I know, like, I'm really satisfied with the observations coming from Alaska, but if I want to ask people to submit observations in Northeast or Missouri Basin or those other areas, what ways can I leverage to, say, promote, for at least one of the examples, to promote Globe Observer, or how they can contribute to those kind of activities?
I'm so glad you asked. So one idea that comes to my mind is we do have a function inside of Globe Observer that allows us to put out a data request to existing users so that people who are already volunteering with Globe in the regions that you're interested in can, when they open the app, see that request, that they go take river ice observations specifically. So that person might be really interested in observing clouds normally, but when they see that request, they might be willing to go also observe river ice. And so that's something we can definitely work with you to put into the system. And I think that's a really easy first step. The other thing that we would want to talk about, and this could be a broader question, is how do we then engage communities in those areas to bring in new users and additional volunteers who are willing to participate in a project that monitors river ice conditions. And I think that is something we would want to go out to the Globe community. And there are several people here on the call. I'm seeing that it could be very instrumental in reaching out to the community to ask for those kinds of observations. So I'm going to let others respond to that.
Well, I don't know. I think the tool that we have to push things out, but I think, using the example of the recent eclipse, for example, we had some success with working with libraries. So, Globe traditionally has a lot of strong connections to schools, but we also have found there are other sort of more informal audiences that could be, if you found libraries in the right area, they could then share the opportunity. And I think it can be a multi-pronged approach to because, like I said, I think people really like to know that their data is useful to a scientist, useful for a project. And I think that can be really compelling to people. So I think if we can identify the areas and the time frame, then there might be some there might be ways we can promote it to community gathering places like libraries or schools or other folks that are already engaged with Globe in some way and are looking for something more to do with the program.
Right. So if you wanted to work with us to write up a project description, thanks for joining us, Amy. Then we can work that through the Globe Implementation Office, get everything kind of polished and ready to go, and then send it out to Globe. We could send it out to there's a NASA library network we can send it out to. We could send it to SciStarter, which is a broad community of citizen scientists. There's a number of educators. So I think we can disseminate it to multiple networks and provide that opportunity if that's something that you would be interested in.
Fresh Eyes on Ice is on SciStarter, and we did propose, but the push and the advertising help always from NASA and from Globe always helps get people hooked. We did, Mohammed, the Globe Network is pretty powerful. After the annual meeting, all of a sudden Fresh Eyes on Ice had members from 42 different countries as a part of our group already. So I think we can expect more geographic diversity this coming ice season, just because of the power of Globe for connecting people across the world. We also did an analysis, Kristen, of we got the GPS locations of all the libraries in North America, and using GIS, we looked at how many were within walking distance of a river or a lake.
Ooh.
And so there's like thousands of libraries within a short walking distance of a river or lake. And so we did propose if we get funded by the next NASA call, we did propose to do a NASA at My Library collaboration and develop some library delivery activities. So yay! I hope keep your fingers crossed, everybody. So Mohammed will get more analysis.
Katie, I love that you did that to figure out which libraries are within. That's very cool.
Yeah, it was an easy GIS question.
Yeah, very cool, very cool. Yeah, and I think what Kristen and Katie have said, fantastic. But giving presentations like this, to groups or the blog, being excited. You are demonstrating your excitement, and you're giving back to the people who are submitting the data. So there's a mutually, if you want, beneficial collaboration you have with people and your own work and how you're using your work. Because everyone really wants, based deep down, all of us want to make this a better world, right? And we want to play a part in that. There may be the odd person who's not in that vein, but most of us do. And so if this gives them an opportunity to do that. Yeah.
Thank you, Becky. So we are at 12:30. It's just when we usually wrap up. I'm happy to stick around if people still have questions.
Just awesome work. Thank you so much. You inspire me. So
thank you. Thank you so much.
I might have to quote you on the value of citizen science. That was a very eloquent response. Thank you.
I also just want to say that one thing that makes this pretty special is you see Jorge here in the audience and Mohammed. These guys show up. The Stevens Point crew shows up in person, and they're relationship builders also. So it's not unidirectional, and I think that's the heart of Globe community and of citizen science. So thanks, Jorge. I see you there. Thanks, Mohammed. You always show up and you keep showing up to make sure people know that there's a reciprocal relationship. So
thank you, Kate.
All right. Any last questions, comments? Well, thank you again, Mohamed, for coming, for presenting your work. It is very inspiring, and I'm super glad to have multiple ways to share it with the community. So folks, our next Globe Observer Connect is actually on August 29th. We don't typically have more than one a month, but this month we had skipped July, and so we decided to hold another. And this time, this next time is also from Alaska. Christy Buffington will be joining us with a student, Sunny. I hope I'm pronouncing the way she pronounces it correctly. Who they went on a tall ship voyage in March and did Globe Observer at sea, which is a really interesting way to get globe data, different kind of data collection. So we'll have them come and talk about that experience and invite folks to share maybe the unusual places they've collected globe data and what it's like to take globe on vacation or to a different kind of place. So that will be the theme on August 29th. That one will be at 8 p.m. Eastern Time, which is 0000 UTC on the following day, on August 30th. So we hope you can join us then. Thank you, everybody, and especially thank you, Mohamed.